Good day, everyone. I am John Michael J. Teves, and I will be reporting about inverse circular functions and trigonometric equations, specifically trigonometric equations number 2. Here are the learning objectives. At the end of the lesson, the students can find an equation with a half-angle identity, solve an equation using a double angle identity, and solve an equation with a multiple angle. In this lesson, we discuss trigonometric equations that involve functions of half angles and multiple angles. Solving these equations often requires adjusting solution intervals to fit given domains. Example, solving an equation with a half angle. Solve 2 sine x over 2 is equals to 1 over the interval 0 to pi. Solution, to solve the interval 0 to pi, we must have x which is greater than or equal to 0 but less than 2 pi. The corresponding inequality for x over 2 is x over 2 is greater than or equal to 0 but less than pi. To find all values of x over 2 over the interval 0 pi that satisfy the given equation, first solve for sine x over 2. 2 sine x over 2 is equals to 1. This is the original equation. Sine x over 2 is equals 1/2. We just have to divide both sides by 2. The two numbers over the interval 0 pi with the sine value 1/2 are pi over 6 and 5 pi over 6. X over 2 is equals to pi over 6, or x over 2 is equals to 5 pi over 6. This is a definition of inverse sine. Now there is x equals to pi over 3 or x equals 5 pi over 3. We just have to divide it by 2. The solution set over the given interval is pi 3, 5 pi 3, 5 pi over 3. Solve 2 sine x over 2 is equals to 1 for all solutions. The argument x over 2 and the expression sine x over 2 can also be written 1/2 x to say that the value of b in sine bx is 1/2. Period is 2 pi over b, so we replace b with 1/2 in this expression and perform the operation. The period is 4 pi from 2 pi over 1/2, then following the rules of division, which is taking the reciprocal of the denominator and proceed to multiplication. 2 pi times 2 is equals to 4 pi. All solutions are found by adding integer multiplies of 4 pi. Pi over 3 plus 4n pi and 5 pi over 3 plus 4n pi, where n is any integer. Another example is solving an equation using a double angle identity. Solve cos 2x equals cos x over the interval 0 to pi for all solutions. Solution, cos 2x equals cos x, it is an original equation. And 2 cos squared x minus 1 is equals cos x, that is a cosine double angle identity. And then 2 cos squared x minus 1 equals to 0. We just have to subtract both sides by cos x, and then we have to factor it out. The 2 cos x plus 1 times cos x minus 1 equals to 0. And then applying the zero factor property, ang nag-result siya ng 2 cos x plus 1 equals 0 or cos x minus 1 equals to 0, and then solve for cos x. In 2 cos x equals 1 equals 0, the value of cos x is equals to negative 1/2, and the value for cos x minus 1 equals 0 is cos x equals to 1. If we use the unit circle to analyze these results, we recognize that a radian measured angle having cosine negative 1/2 must be in quadrant 2 or 3 with reference angle pi over 3. Another possibility is that It has value of 1 at 0 radian. We can use the figure at the left to determine that solutions over the required interval are as follows. X equals 2 pi over 3, or x equals 4 pi over 3, or x equals to 0. Hence, the solution set is 0, 2 pi over 3, 4 pi over 3. Take note, because 2 is not a factor of cos 2x, therefore, cos 2x over 2 is not equals to cos x. In second example, we changed cos 2x to a function of x alone using a cosine double angle. Third example is solving an equation using a double angle identity. Solve for sine theta times cos theta is equal to square root of 3 over the interval 0 degrees 360 degrees. Solution: 4 times sine theta cos times cos theta is equal to square root of 3. That is an original equation. And then 2 times 2 sine theta cos theta is equal to square root of 3. Ang tag-gawas rangani ang 2. Tag-factor na siya. And then, applying the sine double angle identity, which resulted to 2 sine 2 theta is equal to square root of 3. And then we divide both sides by 2. From the given interval theta, which is greater than or equal to 0 degrees but less than 360 degrees, the corresponding interval for 2 theta is greater than or equal to 0 degrees but less than 720 degrees. Because the sign is positive in quadrants 1 and 2, solutions over this interval are as follows. 2 theta is equal to 60 degrees, 120 degrees, 420 degrees, and 480 degrees. The reference angle here is 60 degrees. It is manotice na 60 plus 60 is 180, and 420 plus 60 is 480. Therefore, the reference angle is 60 degrees. Or theta is equal to 30 degrees, 60 degrees, 210 degrees, and 240 degrees, which is divided by 2. So, the reference angle is 30 degrees, kaya divide na to ng 2. The final two solutions for 2 theta were found by adding 360 degrees to 60 degrees and 120 degrees respectively, which gives a solution set 30 degrees, 60 degrees, 210 degrees, and 240 degrees. Solve for sine theta cos theta is equal to square root of 3 for all solutions. Here is the solution. All angles 2 theta that are solutions of the equation sine theta is equal to square root of 3 over 2 are found by adding integer multiplies of 360 degrees to the basic solution angles 60 degrees and 120 degrees. 2 theta is equal to 60 degrees plus 360 degrees n, and 2 theta is equal to 120 degrees plus 360 degrees in n. Here is add integer multiples of 360 degrees. Add na siya ng 360 degrees multiplied by any integer. Or theta is 30 degrees plus 180 degrees n, and theta is equal to 60 degrees plus 180 degrees n. Divided sa pa, which is divided by only by 2. All solutions are given by the following set, whose 180 degrees represents the period of sine 2 theta. 30 degrees plus 180 degrees n, 60 degrees plus 180 degrees n, where n is any integer. Note that solving an equation by squaring both sides may introduce extraneous solutions. Extraneous values rather. This is used in the next example, and all proposed solutions must be checked. Another example is the last example, solving an equation with a multiple angle. Solve tan 3x plus sec 3x equals to 2 over the interval 0 to pi. Solution. One way to begin is to express the left side in terms of secant. Tan 3x plus sec 3x equals to 2. It is the original equation. Then tan 3x equals 2 minus sec 3x is, we just have to subtract both sides by sec 3x. And then tan 3x squared is equals to 2 minus 6 sec 3x squared. It just have to square each side. And then tan squared 3x equals to 4 minus 4 sec 3x plus sec squared of 3x. This was just multiplied o ito pagikan pag square. Nagamit na to ang FOIL method to get that result. And then sec squared 3x minus 1 equals to 4 minus 4 sec 3x plus sec squared 3x. As you can notice, there is a before pa yung solution. Ato ani kay tan squared 3x, ani di ba? Tapos pag dire na sa ubos is sec squared 3x na. Kaya kung ano, replace tan squared 3x with sec squared 3x minus 1. Amo zaon na change na siya. Then just have to simplify. So it resulted to 4 sec 3x equals to 5. And then divide both sides by 4 to obtain sec 3x equals 5 over 4. And then we have to take the sec theta, which is equals to 1 over cos theta, meaning 1 over cos 3x equals to 5 over 4. And then we have to use the reciprocal, and it is cos 3x is already equals to 4 over 5. Kaya nagkuha man nato sa reciprocal ng 5 over 4, which is 4 over 5. Multiply each term of the inequality x is greater than or equal to 0 but less than 2 pi by 3 to find the interval for 3x. 0, 6 pi. Use a calculator and the fact that cosine is positive in quadrants 1 and 4. 3x is approximately 0.6435, 5.6397, 6.9267, 11.9229, 13.2099, and 18.2061. And x, which was divided by 3, is approximately 0.2145, 1.8799, 2.3089, 3.9743, 4.4033, and 6.0687. There is a 3x, and in mga approximate values of 3x is these numbers have cosine value equal to 4 over 5. And then there is a x, mga approximate values ng x kay a total lang kaya nag-divide by 3. Both sides of the equation were squared, so each proposed solution must be checked. Verify by substitution in the given equation that the solution set is 0.2145, 2.3089, and 4.4033. This ends the lesson, and thank you.